What's up, guys? Welcome back to the channel. Today, as you can see there, we have the question paper that you see there. This question paper is actually test 2 that was written last block by these colleges, which is Vhembe College and Capricorn. So it's a common paper for the colleges there. So if you know that you're from Vhembe or Capricorn, you might have come across this question paper here. So today we are going to do question 2 of this question paper. So if you haven't watched question 1, we did it yesterday. You can go to the live stream, but in order for you to watch it, unfortunately, you need to become a member. If you're not a member, then you won't able to watch the video. Right. So we're gonna do question 2. So question 2 of this question paper is actually based on integration. Question 1 was based on differentiation. Question 2 is based on integration. So let me just zoom here. So that we can able to see question 2 there. So we have 2.1, 2.2, and 2.3. 2.3 consists of 2.3.1, 2.3.2. Okay, so we haven't seen some members. If you are a member, guys, please don't forget to chat there. You can comment on the live chat. Only the members can comment on these videos that we are doing, on these live videos, in fact. Right, so if you're not a member, you can only watch. If you haven't subscribe to the channel, because I've made videos for everyone. You can go to the playlist there and also like the video. If you want to become a member, join the membership by clicking the join button underneath the video there. Right, okay, so let's continue here. So let's look at, we're also gonna do 2.4. All this is integration. So I'm gonna start with 2.1. I hope you can see it. Let me just zoom it here so that everyone can able to see them. Here's our 2.1 there. Let me just show you. Here's our 2.1 there. They just say integrate. That's it. Nothing more, nothing less. Integrate. So we are giving this fraction there. So we need to, in fact, we are giving this expression there. So we need to zoom down and write it next to the question. So here's our expression there. We have, this is 2.1, by the way. It's 2.1, right? We have sigma, and we have sine squared x plus cos squared x, and then we multiply, or we divide everything there with cos squared x. There we go. All this is multiplied by dx. So we are integrating with respect to dx. So before we continue though, I would like you guys to look at this expression that is given to us, and then you will have to simplify when it's like this. Most people, they get confused here. They try to integrate with an expression like this. You can't. You need to simplify it first. And simplifying is not integrating, guys. You can simplify before you integrate, and integrate and simplify after integration. So please don't get confused there. So let's look at our numerator there. Our numerator, let me highlight it with red there. Our numerator, here it is there. We have sine squared x plus cos squared x. This, guys, we all know this one. If you don't know, then this is equaling to 1. It's what you call the square identity. If you still remember the square identity, when you have sine squared x plus cos squared x, this is equaling to 1. So we rather change that and equate it to 1. So let's do it. So we're gonna substitute our numerator with 1 there. So we're gonna be left with cos squared x and then dx, right? Still simplifying. As long as we're simplifying, the sigma and the dx is going to be there. We are simplifying. We're not yet different integration. I mean, integrating. Right. So from here, we have 1 over cos. Guys, if you still remember the inverses or the reciprocals, 1 over cos, it's sec. Right. Already done these videos on this. You can go to the playlist and check them out. Okay. 1 over cos is sec. So you can change this 1 over cos that we have there into sec. But let's look at 1 over cos that we have there. It's not just 1 over cos, it's actually 1 over cos squared. So if you change this is going to be sec squared x and then dx. Now that you've simplified, you can start integrating. Very, very simple. Guys, be very, very careful. Don't just rush into integrating when you have a fraction or a expression like this one. Right, so let's go to the formula sheet and see if we can integrate sec squared. Right, so if you go to the formula sheet, now let's look at our formula sheet here, guys. Let's look at our formula sheet. Oh, what happened there? Okay, let me just do this very quickly. Right, so let's go to our formula sheet. If you look at integration, let's go underneath there. On our formula sheet, the integration is this part here. Just write very quickly. Is this part here, right? So as you can see, we do not have sec there. I don't see sec even here. We do have sec though for this one, but the sec that we have, it's squared. We don't. This one is for only sec. What we have is for sec squared on our problem there. Let's go and see. This is what we have there, guys. Right? We have to integrate sec squared, not sec. So don't fall for this trick. So what is it that you must do? The integration of sec squared, it is there, guys. It's just that it is not given in a plain sight. It's hiding there, guys, in the hindsight. Let me show you. Remember, when you integrate, you are doing the opposite of differentiation. So if you remember this table here, when you go this way, it's y and then dy over dx. So we are differentiating. But if we go backwards, we are integrating. Remember, integration is the opposite of differentiation. So if we go backwards, we are integrating. So if you look at this side of the table, this column here, all these are differentiation. So we have sec squared. Here's our sec squared here. You guys see? I hope you can see. Now, if you look at the integral of sec squared, it's gonna be tan. I hope you guys manage to see this. This is a very tricky question that they like on N4. So this is gonna be your integral. So let's go back to our question. So we have sec squared. So the integral of sec squared is just gonna be tan x plus c. So I hope everyone is fine with this. That's basically how you answer this question here. So this question was out of 3 marks. So guys, if you didn't understand, you can leave a comment on the chat, but only the members can able to ask questions. Then if you're not a member, you can only watch, guys, and maybe subscribe and like the video. But if you want to become a member, you can join the membership, guys. No problem. You can able to comment on these live streams and also suggest a question paper that you would like us to do. Right, but we are done on this one. So I am not stopping the stream, guys. I'm only pausing so that I can able to do number 2.2. Right. Right. We are back. Now here's our 2.2 there. Now 2.2, let me show you 2.2, guys. Here's our 2.2 there. Now here they say determine. Now I hope you can see this. Let me just zoom this very quickly. You have sigma there with upper limits and lower limit. and the function there is 3 cos 3x dx. So these are limits because we have the upper limit and lower limit. So they say determine. Basically, they want you to calculate the limit of this expression here. So I'm going to zoom down here, write the question on the empty space there, and then we solve it. Look, here's what we have, guys. We have sigma, right? And then we have pi, and then we have 0 there. And then we have 3 cos 3x, and then dx. So this is the question. And I say determine, determine. So what you can do here, guys, this is tricky. I need you guys to pay attention to this one. Whatever you're doing, please pay attention to this, because it always tricks people, this one. And I tell people, pay attention to this. Look, your limits, as you can see there, it's pi, and then the other one is 0. For the fact that we have a trigonometric ratio as a function, we have to change this pi into degrees, because this pi is actually rads. So in order for you to change from rads or radians to degrees, you must do the following. Okay, you must multiply your rads, right, with 180 divided by theta, divided by pi, I mean. So if you do this pi divided by pi, this is going to give us 180 degrees. So this means that pi is equivalent to 180 when you turn it into degrees. So you just write it here so that you can remember it, right? 180. 0 is just 0. It's not in radians, it's not in degrees, it's just 0, guys. In radians, 0 is just 0. In degrees, 0 is just 0, just in case you're wondering about 0. So you change this, right? After changing this into degrees, if you don't want to change your pi into degrees and you want to continue with radians, you can always change your calculator settings into radians, and then you write pi there. Now, this is limits, guys. So before you continue, what do you do here, guys? You have to differentiate. We have to integrate. Sorry about that. So this is the integral of, we need to find the integral of 3 cos 3x. Now, if you don't know the integral, you go to your formula sheet. Let's go to our formula sheet. Let me go to the integral space. So here's our integral. Here's our integral box there, guys. Do you guys see? So the integral of cos, as you can see here, it is, I'm going to highlight with this red color. It's actually sine x plus c, right? But the cos that we have here on our question is not just cos, it's 3 cos 3x. So consider this 3x there, the coefficient of 3. So when you integrate, obviously we have to multiply by 3 the coefficient there, right? And then the integral of cos, we know that is going to be sine, it's positive sign. But then we still have that 3x. Do not forget it, 3x, right? Because we are integrating, we always divide by the coefficient of x, which is going to be 3. Let me highlight it with red. The coefficient of x, we divide by it, and then we say plus c. If you continue, let me just fix this 3 here, it doesn't look like 3. If you continue, right, this 3 and the coefficient 3 there, they're going to divide each other. So your final answer here, it's actually sine 3x plus c. But since we are doing limits, you have to do the following. You put this inside there. So what do we have there? We have 180 as your upper limit, and you have 0 as your lower limit. Remember, 180, this 180 there, guys. Please don't forget, right? And the c there is not that important, but put it just in case you don't want to get confused after integrating. So now what you must do there, the second step or the following step, in fact, you have the bracket of the upper limit, which is sine 3x plus c, and then you write the upper limit. Guys, these are not powers, these are limits. And then always you minus with the bracket of the integral with the lower limit, which is going to be, in this case, 0. That's 0 there. It's our lower limit. Then from there, we substitute. Oh, I forgot plus c there. Plus c. There we go. There we go. Usually, I don't include plus c, but I'm including it now so that if you put plus c, or someone asks me, is c important? I'm like, it's not important. But if you want to put it, it's still, you're going to get the right answer. So I'm trying to show them here. Okay, so on this first bracket there, it's for the upper limit. Always, guys, it's gonna be minus by the bracket of the lower limit. Always, always. Don't make that mistake, guys. That's the formula, and it's not there on the formula sheet. So make sure that you remember that. All right. So from here, what do we do now? Now we substitute x with the limit. So we have sine, right, 3 multiplied by 180 degrees. Remember, 3 multiplied by x. So instead of multiplying by x, we multiply by 180 plus c. There we go. Then we have the second bracket of the lower limit there. Wherever there is x, we substitute by 0. So you're going to have 3 multiplied by 0 plus c. There we go. Hope we are still together, people. I hope we are still together. Okay. Now, from here, you can use a calculator. I have my calculator with me. So if I insert sine, let me just say sine 3 multiplied by 180, I am getting 0. So this is going to be 0. Inside there, we have 0, right? Plus c, okay? Minus. And then let's do the other one. If we insert sine 3 multiplied by 0, which is the same as sine 0, we're going to have 0, okay? So we're going to have 0. So this is going to be 0 as well. 0 like this. Plus c. There we go. So if we continue, this is going to be 0c, right? Minus c. This c there minus that c there. Then our final answer is going to be 0. So we do not have the limit here. Unit square. We do not have the limit here. I hope you guys understand. I hope you guys understand. We do not have the limit on this one. It means that our limit is 0. So you're supposed to do everything though, just in case you were not so sure. Okay. Now people, I hope you understood. And if you didn't understand, you can always comment on the chat. If it so happen that you're not a part of a member, you won't be able to comment there on the live chat, guys. You can only watch. But no worries, you can always subscribe to the channel. You can able to see other videos on the playlist. If you subscribe to the channel, guys, you will also be notified. So the limit here is, I mean, the unit or the area is 0. Okay, so I hope we understood. So I am not stopping here as well. I am actually going to pause the stream, erase this one here, and then we do the 2.3, which is one of the longest questions, but it has lots and lots of marks. So do not go, because this is a very important question that they always ask on the final. All right, guys, we are back. Let's look at 2.3 there. Now I hope you can see 2.3. Let me zoom it again so that you can able to see the statement and we can able to analyze the statement. Now look, 2.3, you are given two functions there. We have y, right, minus x squared, and y, or y is equaling to x squared, I mean, and the other y is equaling to x plus 2. So these two functions here are actually graphs. So you must able to draw these graphs and you must able to identify what type of graphs are these. Now the question is 2.3.1. This is sketch the graphs given above there. So these two graphs, you must sketch them. And then they say calculate the point of intersection. The point of intersection, it's where the graphs actually touch each other. So, and then they say calculate and also show the area bounded by the graph. When they say the area bounded by the graph, they say the area that is created by these two graphs. So this is what they mean there. The point of intersection, it's where the graphs touch each other. All right, and then the area bounded by the two curve and the area bounded by the two curves and also indicate the representative strip. So we also need to show the representative strip there that will be used to calculate the area. So these are the things that you must do here. First, you draw a graph. I forgot to highlight sketching. So you draw the graph that are given to you, these two, one, two there, and then you calculate their intersect, this part here, right? And then you show the area bounded by the two curves. They show the area that is created by these two graphs that they want you to draw them, and also show the representative strip on that area. Okay, so I hope you understand this question. This question here, it's 6 marks. So you must know your graphs, guys, when you do this one. If you know that you're struggling with graphs, then this is going to be a serious challenge. Let's start with y1. Let's call this one y1. Y1, it's equaling to x squared, right? And y2, let's say, is the one that is equaling to x plus 2. There we go, right? Just call them y1 and y2. It's very important. Now they want us to draw the graphs here. Let's start with y2. What type of a graph is y2? Just in case you didn't know, guys, y2 is actually the straight line graph. So we need to find the coordinates. So it's very simple. Let me just write line there, right? Line. This is the calculation of a straight line graph. All right. So when x is 0, what is your y, right? So meaning on y2, when we put x0 there, what is going to be our y? So y is going to be 0 plus 2. We substituted 0 there, guys, right? So meaning y is equaling to 2. So we can call this one point A, where x is 0 and then y is 2. Simple. And then let's do another one. When y is 0, what is our x, right? Still we are doing this one, the line graph, guys. Okay, I'm going to highlight with red to show that we are calculating the values or the coordinates of the straight line graph. So when y is 0, what is our x? So we're going to substitute from the original, this one here. Okay, let's do it. So let's substitute 0. We're going to have 0 is equaling to x plus 2. So we know that x is going to be, if we transpose 2 to the other side, it's going to give us negative 2. So point B, let's call it point B, x is negative 2 and y is 0. Guys, when you draw a straight line graph, don't stress yourself. You only need 2 points, nothing more, just 2 points. This A and B points are enough. Remember, you just need those 2 points, then you connect, and then you have a straight line graph. Okay, so let me create a little bit of space here again so that we can able to draw a graph. So let me just do it here. Just do it here. Let me just do it here. Yeah. Okay, we're gonna need space here, but I think here is gonna be good. So let's say we have this graph here. Okay, so we have your cast diagram or your Cartesian plane there, x and y, 0 point there. You don't really have to draw the points 1 and 0. You don't need to write the intervals here, guys. It's straightforward, it's a straight line. But if so happen that you can't do it this way, do the intervals. Let's start with point A. Point A, it says when x is 0, y is 2. So x is 0 on the y axis. So we can say this here, this point here, y is 2. There we go. Simple, straightforward. Okay, let's look at point B. Point B, it says when x is -2, y is 0. Y is 0 on the x-axis, and -2 can be somewhere there on the x-axis, right? You have 2 points. Now it's time for you to connect the dots. So let's connect the dots. So it's very simple. Like I said, people, there we go. See, here's our straight line graph, guys. There's our straight line graph. Simple, straightforward. And then you name it y. Let me just name it here, y2. Okay, y2, right? For now. And then let's look at this graph here, y1, right? Y1, as you can see, guys, it's actually parabola, but it's not a normal parabola, guys. How do you know it's a parabola? You have x to the power of 2, guys. The minute you have a graph that has y is equal to x to the power of 2, it doesn't matter whatever that follows. Okay, as long as the highest power is 2 of x on that graph, just know that it's a parabola. Given that y does not have the power of 2 as well, that will be completely different. But in this manner, this is actually a parabola. Now, this one, it's a parabola that doesn't have I mean the coefficient of x. Also, it doesn't have a c, a constant, right? Remember, a parabola, it's actually from trinomial, something like this, guys, right? There we go. We only have this part. B0, C0. If you still remember the parabola, C is a intercept of y. So if the intercept of y is 0, this graph of ours, guys, this graph of ours, it, it tends and cuts at 0. But where is it facing? Facing downwards or upwards? Since our coefficient of x squared, which is a, it's positive 1 there, it means our graph must face upwards. So when you draw this graph, guys, this is how you're supposed to draw it. This is how you're supposed to draw it. Oh, let's use the red color. I'll try to be as patient as I can. This is how you're supposed to draw the graph. You cut at 0 like that. You don't have to think too much for this one, guys. Cut at 0 and off you go. You guys see? There is our graph there. There is our graph. Simple, straightforward, guys. So this graph is going to be y2. There we go. I mean y1, not y2, guys. Sorry about this. Y1. Right. Look at this graph. They are intersecting here and there. Now, the question that follows, if you were paying attention to the analytic of, or when we were analyzing the question, they said you must get the intercept of these graphs. Okay. The intercept. They are talking about these 2 points that I just did there. Right. So since both of these graphs are equaling to y, see, even though I named them y1 and y2, but they're both equaling to y, meaning you can equate these two graphs and try to find the x values of those graphs, of those points. So let's do it. So you can say x squared is equaling to x plus 2, right? This is y1, which is equaling to y2, which is x plus 2. Right, then you solve for x. I'm going to transpose x plus 2 to the left hand side. They're going to be negative x and negative 2. And this is going to give us 0. Now we simplify. We factorize. Let's factorize and solve for x there. Know that this is x and that is going to be x. The factors of 2, when you subtract, they give you 1. It's 1 and 2. 1 and 2. So the one in the middle must take the sign of the bigger factor. So let's do this. The bigger factor is 2 is the one that must take the sign in the middle there. And then this is going to be 1, or this is equaling to 0. Meaning now our x is going to be negative 1 and our x is going to be 2. Right. Simple. Now that we managed to get our x, it's time to find the y values of these coordinates. Remember, we need to find the intercept. So if you find the intercept, you need to find the y values. So how do you do this? This is the question that I also asked by N5s. So if you're paying attention, make sure you pay attention to this. Guys, if you want to find the y values, you take one of these formulas, whether y1 or y2, and substitute the x values there. I'd rather take y2. So if you say x is equal, I mean y is equaling to, we use this one here, guys. You can take the first one, it's still fine. If we say when x is -1, we just substitute with -1 there plus 2. So our y is gonna be, 1. There we go. So meaning this point here, one of the intercept, let's call it intercept 1, and let's call it intercept p. Okay, you can call it whatever. It's when x is -1, y is what? Y is 1, right? So which one could it be? I would say is this one here. Is this one. I can call this one p because our x is -1. So negative for x, it's this side. Do you guys see? It's this side. So it makes sense there. And then when x is now 2, right? When x is 2, then we just substitute again on this formula again and try to find the y value. So we're just gonna say 2 plus 2, and then y is gonna be 4. So let's call this one point q, right? When x is 2, y is gonna be 4. Q is this point here, guys. It makes sense again. It makes sense because as you can see, our y is, our x is positive this side. Do you guys see? So as you can see, our x is 2 there. So it makes sense. Okay, so that's how you get the intercept there. That's how you get the intercept. Now, if you still remember the question says indicate the area that is created by the two graphs. Guys, don't fall for this trick again. Let me use a different color this time around. Try green. Okay, look, when you are looking for the right area that is created by these two graphs, be very careful because we also have this one area that is enclosed there. You are seeing the whole of this part here, the whole of this part is the area that is enclosed, but it's not created by only um, two graphs. It's also created by the x-axis. So that's not it, right? We have this one here, this one here. There we go. This area here. You can see it is made out. It is made out of is made up of these two graphs. So this is the area that they're talking about. So they want us to indicate it and also show the representative strip. I'm gonna use yellow to indicate it. So you in the you use your in your when you're in your exam, make sure that you indicate, guys. These are marks. People who are marking this, if you don't indicate, you're gonna lose marks there. Okay, so that's the area in yellow. And then they say show the representative strip. Guys, the representative strip, you don't have to stress yourself. Just put it inside the shaded area, anywhere inside, anywhere. Let me put it here so that everything can show there. Put it anywhere as long as it is inside. See, you put the strip there, then next to it you just write change in x, and then you have your full marks for that question. That's it. This is our question for 2.3.1. That's it. Out of 6 marks, this is your 6 marks there. It looks difficult, but really it's not, guys. It's not at all. It is really, really not. Okay, now let's continue and let's see the other question. So if we go to the question, I'm not going to pause. I'm just going to go straight to the question. Let me zoom it. Now we have to do 2.3.2. We are done with this one here, which is 6 marks there. We indicated the area. Let's see. We sketch the graph. We find the intercept. We indicated the area. We show the representative strip. So we are fine. So let's look at 2.3.2. They say the magnitude, or they say calculate the magnitude of the indicated area with the aid of integration. So now they want you to calculate the magnitude of the representative of the area, I mean, that you highlighted there. So let's go to that graph there. Let's go to the graph. Okay, so they want us to calculate the area using integration. Now, remember the other question that we were busy with, the one where we have the upper limit and the lower limit. Now, we're going to use that information similar to that one. Now, when you have two graphs and you have to calculate the area, here's the formula here. You'll have x, you'll have a sigma, right? This sigma, you're going to have the upper limit. Let's just call this one x2. And then you have the lower limit. Let's call this one x1. Now, you'll have f of x or y1 minus y2 or y2 minus y1. It depends on your graphs. Let me, for this one, it's going to be y2 minus y1. I'll explain this, then dx, right? Why y2 minus y1? Because someone can ask, why don't you start with y1 minus y2? You don't just write this, guys. You look at your graphs. So let's zoom the graph a bit, guys, so that I can able to explain this. All right, here's our graph there. Now look, the area that we highlighted, again, I'm gonna show in green. You see this area here that we highlighted is the one that is gonna help us which graph is gonna be positive, which graph is gonna be negative there on our formula. So let me just go back. Now, the one that is positive, it's always the graph that it's on top of the area. Let me use the color of that graph anyway. This graph here that is on top of the area, which is the straight line graph. Do you guys see? We call it y2. So it's the one that is going to be positive because it's on top of this area that we calculated, right? And then the one that is below the area, or that is below the graph on top, which is y1, this one here, the blue one. If you look at the area, this one is underneath the red line there. This means that this one is y1, so it's going to be negative. Basically, that's how you actually write this formula here on this side. Okay, you don't just write y1 minus y2. No, you look at your graph. The graph that is on top of the area is the one that is going to be positive. In this case, it's y2 for us, right? And the graph that is below the area, it becomes negative. In this case, it's y1. So here they are there, guys, right? Right. And then dx over, oh, multiply by dx. Now that I explained that, the limits, okay, the limits. Let me zoom down now. Let me explain the limits. As you can see, we have the upper limit there. I never wrote which one is it. I wrote x2 there, and the lower limit it's x1. These are just representative. But your limit should be, guys, your limit should be the x values of q and p. Now, those are your limits, guys. Let me just do this. If you're watching this from the beginning, the x values or the x coordinates, these ones here, -1 and 2, those are your limits. But then, which one is the upper, which one is the lower? Well, the bigger one is the upper, and the smaller one is the lower. As when you compare 2 and -1, which one is bigger? 2, it's bigger. So when you rewrite this, you're going to write like that. The upper limit between 2 and -1. Remember, you take the x values or the x coordinates of p and q, or the intercept, right? So 2, which is bigger, is going to be the upper limit. -1 is going to be the lower limit. Now, let's go back to this now. Remember, y2 is the straight line. So straight line, the equation was x plus 2. There we go. Minus, don't forget we have minus there, right? y1. y1, remember, it's x squared. So you close there, and then you have this here. Then from there, you can start integrating. Let's integrate. This is a standard integral, guys. So let's integrate. I hope everyone understand this, guys. Okay. Yeah, if you really find this to be useful, don't forget to like the video. So let's do this. right? And subscribe as well. Let's integrate this. So when you integrate the first term there, which is x, is a standard integral. It's gonna be x, right? 1 plus 1 divided by 1 plus 1. Remember, I have x to the power of 1, so 1 plus 1 divided by 1 plus 1. Guys, when you integrate, you divide by the power that you got there, right? On a standard integral. Now this one here, it's a constant, guys. When you integrate the constant, not differentiate, guys, when you integrate the constant, you always write the constant and then you multiply it by the variable you're integrating with. In this case, we're going to multiply by x, so it's going to be 2x. Don't do these complicated things of x to the power of 0 plus 1 divided by x divided by 0 plus 1. It's a waste of time. Okay, just multiply your constant with a variable there. In this case, 2 multiplied by x, then we're done. And then we come to this one. We have x 2 plus 1, and then we have 2 plus 1. Then we close there. Remember, you don't put c there, guys. Even if you put plus c, it's fine, but don't put it. It's a waste of time. And then we have 2 there. We have negative 1. Those are still limits. Remember, the limits, they are not powers. So from here, you can start. The first bracket is for the upper limit. So if we say x to the power of 1 plus 1, this is going to be x to the power of 2 divided by 1 plus 1, that is going to be 2. The middle term is fine, it's just going to be 2x. And then the third term is going to be negative x to the power of 2 plus 1, which is 3, divided by 2 plus 1, which is 3. And then we have this one. So there you write the upper limit, not exponent, the upper limit, guys, right? And then the very same integral, you write it there, but this one here is for the lower limit. So once you integrate once, you don't have to reintegrate again. Negative 1 there. So this here, guys, please don't forget, these are not powers, they are limits. Okay, they are limits, right? So let's continue. Now it's time for us to do some substitution. When you do substitution, guys, just make sure you put your substitution inside the bracket. For example, for the first bracket, the upper limit is 2. So to the power of 2, wherever there's x, we put 2 there, guys. Then we put 2 plus 2. Wherever there's x, we put 2 there. Minus, we have 3. Oh, we have minus, we have 2. Remember, x to the power of 3 divided by 3. There we go. And then you minus this, right? And then the first one there is going to be minus. Put it inside the bracket. Minus 1 to the power of 2 divided by 2 plus 2 and minus 1. Then minus. Then we have negative 1 to the power of 3 divided by 3. There we go. Do you see? This is a direct substitution, people. So you just do substitution there. Right. Right. If you remember and you didn't understand, please comment there on the comments. If you understood, it's fine. We gonna continue. So I always tell people, rather put this on the calculator separately. Don't put the whole thing on the calculator, because if you put the whole thing on the calculator, chances are you can make a mistake there, and then once you make a mistake, you have to start over again. Or to find out you made a mistake only on the first one there. So don't do that, guys. Avoid putting the whole thing on the calculator, because it's easier. At the same time, it's easier for you to make mistakes on the whole thing there. So let me just put everything there on the calculator and let's try to get the answer there. Right. So let's see. I have okay, everything is fine. Let me see. Okay, so for the first one there, for the first paragraph, for the first, we have 10 divided by 2, or 3, in fact, not 2. 10 divided by 3. Then we have to do the second one, the second bracket, right? So let's do the second bracket. If you do the second bracket, again, we're gonna have let's do it. We're gonna have negative 1, right, squared divided by 2, right? Don't forget to put inside the bracket, guys, plus, and then we have 2 multiplied by negative 1. There we go. We have minus, and then we have negative 1 right, to the power of 3 inside the bracket, by the way, divide by 3, and this is going to give us negative 7 over 6. So negative 7, so we have this negative there, and also this is also negative 7 over 6 there, right? So this is the calculations. I hope you also check. If it doesn't make sense, please comment there, but I think I did the right thing there, guys, right? So this, obviously, if you put it in the calculator, you're gonna have 10 over 3, negative and negative, they're gonna give you positive. So this is basically gonna add each other. So the final answer, let's look at the final answer. What is our final answer? Our final answer, let's go with 10 over 3 plus 7 over 6. What do we get? So our final answer is 9 over 2. So I'm getting 9 over 2, or 5,5, 4,5 unit square. Remember, we are calculating the area. So this is how you do this one. It take a little bit long, but I hope you managed to understood this, guys. Hope you managed to understood. Kind of took some long time because no one is punching the calculator. For me, I'm punching it for myself. So this is how we managed to do this, guys. These are free marks. If you can see from the question paper there, I think this is out of 8. This question there is 5. No, it's out of 5. This question, all in all, 2.3 is actually out of 6 plus 5, 11. So I think somewhere there. So I hope you guys are fine. I hope you guys are fine. Oh, Lidwaba, you understood. I'm glad you understood. Right. These are free marks. Do not lose these marks, guys. Do not lose them. They are very, very easy marks. I know it looks intimidating, but do not lose them. And to top up on this, this is what you're going to do N5 and N6. So make sure you understand this, because N5 and N6, you're gonna come across this. We're going to introduce volume for N5, and N6 we're going to introduce more. So know this part here. All right, people, we are done with this one. If you have questions, please leave a comment on the live chat there. Remember, only members can do that. If you're not a member, you cannot do it. So if you want to be a member, there is a join button there. Join and become a member. And you can also come with your own question paper and we solve it. All right, people, I'm going to pause the stream and then we look at the last question, which is 2.4. And then we are done with this question paper. Apparently, they only do 2 questions for these 2 colleges, right? So let me just pause the video and let's do 2.4. All right, we are done with 2.3, guys. Let me just check how many marks was it. Oof, yeah, it was 11 marks. It was actually 11 marks. Question 2.3.1 was 6, 2.3.2, it was 5. So if you come across this question, just take all the marks, guys. Now let's look at 2.4. Now this one, again, it's a polynomial, but for integration. You must know these integrals, guys. I've done videos on different type of integrations for and false. We have 4 types of integration, guys. We have the standard integral, we have the log integral, natural log integral, we have exponential, and also we have trigonometric ratios. So you need to know how to do those ones. So as you can see, this question here, there's all of them. Okay, so here's what I'm going to do. Again, I'm going to copy this so that we can able to have space to do it. Right, so let me just copy it very quickly. We have sigma. This is out of 6 marks, by the way. We have sigma there, right? And then we have inside the bracket, we have 3 over x, I think, squared there, right? Plus we have 7e to the power of negative 7x there. And then we have minus 2 over x. There we go. And then we have plus, okay, 2 divide by sec 2x. Okay, and then we have plus 16, okay, cos 4x. All right, then let's do the last one there. Let's do the last one. The last one we have negative, okay, cosec x multiplied by cot x. There we go. I hope you guys can see. Then multiplied by dx. So we're actually integrating with respect to x, guys. So I'm gonna put it here. I hope you can see. I hope you can see. Right. So the first term, we have to look at it. Now with integration, guys, be very careful. The first term was actually a trick. But before I mention this, I think it's important for me to mention the following. You cannot integrate with certain terms there. We need to simplify them. So each and every term that needs to be simplified, I'll explain to you why we need to simplify them. Let's start with the first term. The first term, we have 3 over x squared. You cannot integrate with x on the numerator, especially x that has the power of 2 or 3 or half. You cannot integrate with that one. So we need to take that x to the numerator. So if we take that x to the numerator, we're going to have 3x. Then this is going to become negative 2. Our exponent changes the sign there. Now we go to the second one. The second term, it is simplified already. So rewrite it like this. Guys, when you integrate at the same time. When you simplify, just simplify. The ones that are fine, you just write them as they are. Now let's look at this term here. Very interesting, guys, this one. It's similar to this, but it's not the same. Let me explain. Whenever you have, remember during integration, when you are integrating, whenever you have x on a denominator, you don't take it to the numerator. This is actually simplified. This one here, don't change it as long as it's x to the power of 1. If it was not x to the power of 1, then that's where you're going to do what you did here by taking this x to the numerator, right? But if it's x to the power of 1, just like this one that we have here, leave it. It's okay. Continue and simplify others. I hope you guys understand. If you have questions, again, you can ask on the comments there on the live chat. So this one, it's simplified. So it's going to be 2 over x, right? Don't take it to the numerator. It's fine. And then this one here, this term here, you cannot integrate with any trigonometric ratio on the denominator. You need to change it so that it can be, so that we can have the trigonometric ratio on the numerator. So we have 2 over sec 2x. Guys, this is an inverse. 1 over sec, we did this yesterday. X is going to be what? Cos. I hope you remember the reciprocals. Just in case you don't know them, you can go to the channel playlist and watch them there. I have made videos on them. Okay, so since we have 2 there, we can say 2, right? Now, 1 over sec, it's cos. But this is not just sec, it's sec 2x. So this is going to be cos 2x, right? And then we say plus there. We have 16 cos 4x. Here they were trying to trick you guys. Don't add this 2 cos 2x with 16 cos 4x. They are not the same. This one is 2x, that one is 4x. They are not the same. That basically means that they have different angles. So don't add them. Okay, it's tempting. Don't add them. Right. I'm just trying to show you the tricks. This one here, this one, the last term, it's very simple for us to try to simplify it. When you come across a, a problem like this one, guys, then I need you to pay attention. Please pay attention to this one. If you come across a problem like this one, where you have something like cosec multiplied by cot, especially when you're integrating, don't simplify it yet. Not yet, guys. Don't simplify it yet. What you need to do here, guys, what you need to do is go to your formula sheet, right? and then go to the table of differentiation. Let's go to the table of differentiation there. Let's go to the table there, and let's look at the trigonometric ratios. Remember, when we go this way, we differentiate, guys. But when we come from that side, going that way, we are integrating. Now, from this column here, let's try to find cosec multiplied by cot x. If you look from here, here is our cosec multiplied by cot. Do you guys see? There we go. Remember, when you go this way, this is going to be the integral of cosec x multiplied by cot, which is cosec x. And this is minus cosec x multiplied by cot x. So in our question there, we have minus. You see, this is minus cosec x multiplied by cot. So if it's there, guys, don't change it. Don't change it. It is there. So leave it. Leave it as we are simplifying. Don't change it. Leave it as it is because we do have the integral of this. Cosec x multiplied by cot x. So be very careful. So before you simplify this type of problems, check whether we have the integral in hindsight there on the table of differentiation. Now let's start. Now that everything is simplified, let's start. Y is going to be equaling to, the first term is the standard integral. How do you see x is the base, guys? Once the x is the base, use the standard integration, which is going to be the following. I hope you know about standard integration, guys. It's going to be 3, obviously, or coefficient. Then we have a negative 2 plus 1 divided by negative 2 plus 1, right? Then plus. Now we come to this one, the second term. This is the exponential. How do you know x is the exponent? People confuse these two. The first one, x is the base, so it's the standard integral. When x is the exponent, just like this one here, it's an exponential. Be very careful, guys. Be very careful. Now, when you integrate, guys, the exponential, okay, we have the coefficient, which is 7 there, right? Don't forget, write it as it is. And then you're going to write e to the power of negative x 7, I mean negative 7x. Then you divide there, you divide by the coefficient of x, which is going to be negative 7, and then you multiply by ln base, which is e in this case. There we go, guys. The formula sheet, it is there. Let me show you on the formula sheet. Here it is. Here it is, guys. Here it is, this one here. Okay, this one there it is. So basically that's what's happening. What is missing here is the coefficient of x, but you always divide by the coefficient of x. Okay, right, let's continue there. Let's continue. Right, so from here we do this one here. This one, guys, whenever you have we do 2 over x. Whenever you have uh 1 over x or x to the power of negative 1, it's a ln or natural log integral. Let me show you again. Here it is. Here it is there, guys. There. Here it is. A over x. A is a coefficient. In this case, a is 2 there on our formula. So it's going to be a ln x, right? So in this case of ours, instead of a, we have 2. Remember? So it's going to be 2 ln x. There we go. And then let's look at this one, the trigonometric ratio. Simple again. So simple. Go to our formula sheet. Trigonometric ratio, we have cos there. Let me go back. We have 2 cos 2x, right? And the integration of cos, it's sine. We underline it. We did it before, earlier on this question paper. But what is missing there now is 2, the coefficient of the cos, and then 2, the coefficient of x. Now, when you integrate this one, you have to multiply by the 2, this coefficient first, and then the integral of cos, we know that is going to be sine. And then don't forget to put 2 there. And let me write it. Write sine, guys. Doesn't look good. Sine, right? And then we write 2x there, right? But since we are integrating, we divide by 2. What is this 2? The 2 is this one, guys. Okay, the coefficient of x is the one that is dividing with. There we go. And then we continue with this one. It's the same thing, guys. I'm not going to go to the formula sheet. 16 is a coefficient, right? 16 is our coefficient. And then the integration, of course, we said it's sine. Then you write the 4x there. There's 4x. But then we said you must always divide by the coefficient of x. This is going to be 4. I'm going to highlight it again so that you can see this 4 here is the one that we divide by them, right? Okay, 16 is just a coefficient. Now remember this one here, we did check it on our formula sheet. When you look at the differentiation table, negative cosec multiplied by cot, when you go back it gives you plus cosec. So guys, this is how you do your integration. Oh, plus c, this is how you do your integration, guys. I hope you understood this, because it can get very confusing. But don't leave your answer like this. Try to leave your answers with simplified version and positive exponents. So let's look at the first term. The first term, we have 3x, right? Negative 2 plus 1 is going to give us negative 1. Then divide by negative 1, right? And then plus. Let's look at this. We have negative 7 divided by 7. This is actually going to become a negative, not positive, right? It's going to become negative. Ln e, guys, is equaling to 1. So this is basically negative 7x, because this here, ln e, guys, ln e is equaling to 1. Please don't forget that, guys. Please don't forget. Right. And then we leave this one. This one is already simplified. 2 ln x simplified. And then let's look at this one here. Plus, right? We have 2 divided by 2. So we're going to be left with sine 2x, right? And then we have 16 divided by 4. What is 16 divided by 4? That's going to give us 4. And then we have sine 4x, right? Plus cosec x plus c, right? So this is your final answer. But try to get rid of this negative exponents there. So let me add another extra step there. But that is our answer there, by the way. That is our answer. So if you get rid of those negative exponents, we're going to have 3, or this is going to be negative because we divide by negative 1. Negative 3 over x, because this is negative 1. So it becomes to the power of positive 1. And this one is going to be minus 1 over e to the power of 7x, right? Minus 2 ln x plus sine 2x plus 4 sine 4x plus cosec x plus c. Right, so this is our final answer. This was out of 6 marks. Usually when it's out of 6 marks like this, we only mark the final answer. 1, 2, 3, 4, 5, 6. In this case now, we are not marking the constant. But sometimes we do mark the constant, guys. It depends on the examiner. I hope you guys managed to understand this. As for Lidwaba, I hope you're still there. I hope you're happy. I don't know whether it was you or it was Tato who requested us to do this question paper. Now I'm hoping that you managed to understand all these questions. Since you're a member, you can able to watch this video offline once we go offline, right? If you don't remember, guys, you're watching it for the last time, you cannot watch it offline again. But if you want to watch offline these videos, you have to become a member. And if you want me to do question papers for you, you have to become a member so that we can communicate via members only group. And then you're gonna send me the question paper and we can able to solve. But then with that being said, tomorrow we're gonna do one of the one from what is it, Gauteng and Free State. Remember, we have common paper on Gauteng and Free State, so we're gonna do corrections on that one. So the Gauteng and Free State, it's out of 3 questions. So I'm gonna do question 1 tomorrow, question 2 maybe Saturday, Sunday, and question 3 on Monday. All right, and then we are done revising. All right, people. I hope you enjoyed this, and I'm glad that you understood Lidwaba. See you guys tomorrow when we do the test 2 that the region of Gauteng and Free State wrote this past few weeks. So I hope you'll be there, guys, as we are going to be do corrections and revision. Right, people. See you on the next stream.